Okay, welcome back. Uh, it is day 141 of coding every day. Um, Back home, um, as you can see by the backdrop. Um, and I'm not actually going to be really coding anything today. Um, I'll write a gimmicky line, but the Lakers versus Timberwolves game is on right now. And I really want to watch that. So I'm recording. It's literally like I'm looking over right now, and they're doing the tip off. So I thought I would just show my computer architecture simulator as it is right now, and show you how good it's working, how good, how okay it's working, more like. But and then that'll pretty much be it. Um, and I'll probably just change some lines in there, and that'll be my coding. I mean, the whole one of not the whole point, but one of the reasons is just to make sure that like when I'm busy with school, like the series is also like to help me at least be like familiar like code just be familiar every day and it's never like getting out of my head for some reason and I'm like forgetting basic stuff. So just like looking over code and changing a few lines, it like don't make it I don't ever want to make it a consistent thing, but like come on. Yeah, give me some. I mean, this is literally going to be like a 400-day series because um I mean, I guess I could get a full-time job in the fall during my senior year, but um, I don't know. We'll see. I don't know how that stuff actually like works with like a fall career fair or something like that. So it's gonna be long. So not every day is gonna be amazing. Anyways, okay, I'll get to the point and we can just go through this. So actually, I want here. What do I even have here? Oh my God. Do we have desktop? Nope. What do I have here? I guess we'll just go to downloads. Get clone CD. Um, okay. Bring this up and this up. CD downloads. Architecture. Um, okay, so this is going. Oh, please tell me I have this right. Is it Python API.py? Uh, oh, it's in here, but also I need to compile this, so I shouldn't even. CD make. Oh, make. Oh. Oh, this is git checkout processor. There we go. So down do we have a make? It's just in here, right? C make. C make path to source. Them. Um, is it make cd build? And is it like C make that? Lakers up by one. Uh, and then just make C make. God damn it. Oh, isn't it like M? Is it? Fuck. Okay, how do I have like how do you run a make file on Windows? Lakers up by 4. Just run ninja. Oh shit. Oh. I mean, I think we're good, right? I mean, this would be CD into or CD back. Would it be in here? It would. Okay. Um. Oh my. Oh no, we are good. API. Go here. .exe. Okay. Will you work now? npm I flask. What? The module name Flask. Oh wait, isn't Flask actually in capital F? Flask in, oh my god. What, Python install Flask? Let me cd again. Alright, pip install Flask. What am I doing? Um, Python. So wait, there's one of this, bro. I absolutely just hate dependencies. Oh my god. Instead of calling pip directly, you use Python and like is up by 5. Like is in 5. Okay. Will you now work CD? Yeah, Berg City over there. Uh, work now, please. Nice. Um, and then hopefully CD GUI Python 3 interface. Dot py? Oh yeah, that is true. Please tell me this works. Oh, money. Oh my god, was that Luca? That was Rui? Oh my god. Lakers in 5. Okay. Work now? No module named Watchdog. Well, actually, I know Watchdog's also like a Linux thing. Oh my god. We got it. Okay. Right. Oh my god, my hair. Oh my god. Yeah, you can see that. Nice. Um, so I'll take you through it. God, my hair. Okay. Um, so basically, my load instructions there. if we go back to here and we go to, I mean, I guess we can actually we'll start the assembler. Um, so the assembler, it takes in a line. So wow, I should actually go back to interface, right? So um, uh, 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 um, actually, I can go up here, and so we have down here we have load instructions, okay, which is what I just did. So this goes to the load instructions file right here. It takes in the file path that we found and we open it as a read, and then instructions is line for line in an array of whatever, right? And then we start a thread and we call to the API, okay? So we go to the API and the API sees load instructions. So it takes in the data, instructions is equal to this at field instructions. And it says, okay, for each instruction, we send this command of write and then the actual instruction line. That goes to send command. Okay, send command uses the simulator process standard input. Simulator process is a sub-process of the executable file that we generated with the make. Um, and so if we go to the kind of base of simulator.c, so this is kind of where everything starts from. And so what happens is we have this while loop, right? So we go into int main, well, we go into int main, um, and we have a while that just pretty much goes on forever. And it's just basically just a standard input. So this is how the API and all these files are communicating. Anyways, it comes in, like we said, with load instructions. We have write. So this talks to store instruction with command. So then we go up to store instruction. That's step instruction. Store instruction. We come through with the command, which is a character array, because in C you don't actually have strings. Um, and then we just go through, we find the address, which is just the program count. Register 15 is our program counter. And then we use our write to memory, which if we go to memory.c, well, first off, you can see the program counter register is initialized here. But write to memory takes the address, goes to DRAM, which DRAM is, I think we initialized DRAM in actually simulator. Let's see. Um, I think it's in a knit system. DRAM idle, blah, blah, blah. Is that all we do with DRAM? Anyways, DRAM's right here. This is our global DRAM variable. I guess maybe it's memory.h. DRAM space is this. And then we define DRAM as this. So I thought in memory though, we like flesh out like initialize of DRAM. I guess not. Anyways, so it just writes to DRAM at that address with the data that we passed through. And that's how this just happened. And then the UI just loads in um, this, right? We have this array of data. I don't know why there's a one offset here. Uh, I messed something up at some point and I never fixed it. But anyways, it just loads in all our instructions here and then also shows them here. So what we can, then we also have this pipeline. So like a normal instruction set architecture or in like a CPU, you're gonna have a pipeline. Or modern day, it's like a lot of pipelines, right? Which has like the five stages of you fetch the instruction, you decode that instruction because it's as a binary. Like these are these instruction encodings, which if we go to the assembler, um, this is what I was going to show was we pass through up here we pass through that character line, which is just the string of the input, which if we go to instructions, this is the input. It's like add R2, R1, R1. We're just a text file. Like each line is this. Like this is one line, this is another, blah blah blah. And so that line is passed in here, and then we just go through and we break down this line, just a bunch of regex stuff. And then we up here, I believe, right here we set like register the opcode register D this to these three values, and those three values are found like through this regex stuff, whatever. So the whole thing is we're breaking down the um we're breaking down the like add R2, R1, R1 into the opcode of add is just 0, 0, 0, 0. It's 16-bit architecture. So the first four zeros is our opcode. The second four is our destination register. So if it's 0, 0, 0, or no, 0, 0, 1, 0 for R2, right? Then this destination register is now 0010. The next 4 bits is our first register that we're adding, and then the last 4 bits is our second register. So that's this. And then we also use an immediate. Um, and so register B and the immediate just share those last 4 bits. And anyways, this just breaks down all of these for each instruction into the bits that we need. And then up here, these for like an RRR, so that add register 1, register 2 to this destination register is an RRR type. This is just bitwise stuff of doing an AND. So we only get the bits that we want out of a shift to 12. So we only take the top 4 bits. And so now we have like a 16-bit of only the bits that we want up here. And then at the end, the encoded string is going to be everything that we wanted. And so when you go here, these are all the encoded strings. Anyways, I'm spending way too much time on this. So I can set a configuration up here, like, and so if you look at the pipeline, this needs to be changed to there's a delay on fetch, right? Because, well, technically, you would never have a delay in an actual system. You'd want it to go as fast as possible, but my professor wants a delay because if you're going to DRAM to fetch something, that needs to be shown that it's going to take longer than going to cache, right? Because cache is quick, DRAM's not. But like in a simulation, you'll never see that if you just have it, this, instant. To decode, that was just at fetch, and our new instruction comes in. This bubble everywhere is because if we go to the instructions, we're adding R1 and R1 to R2. The very next instruction, we're adding R2, right, which we're setting to a new value here. We're adding that value into R3 plus R0, so just R2 into R3. But if you think about the five, stages, once we get to execute on this instruction, the second one, and we see that it wants a value from R2, but we see that this R2 is not at write back yet, right? So the R2 hasn't updated yet, and it's already trying to use the value of R2. And so obviously, if you're writing a program, right? If you say X is equal to this, and then on your next line you say calculate this using X, you obviously want the value that you just changed it to beforehand, right? So this is where you just halt the pipeline until we go to the registers here. um, Register 2 is equal to 2, and then the pipeline moves forward because now this can go to execute. Also, I should have said, or I said it wrong. Doesn't get to execute. It shouldn't get to execute. It should only get to decode because once it gets to execute, it's you know it's bad. It's writing an old value. Um, if not equal, so this just got to execute. Um, uh, Branch if equal, sorry. And so R3 and R2 are equal because we remember we set R3 to R2 plus 0. So R3 and R2 are equal. And so we have the immediate value of 3. So if we come here, we can see that we skipped, um, technically we skipped 2, but how I have it set up, you type in 3. And so this will skip this, and then it'll go to this last value of R9. So you can see the program counters at 7 here and at 4 here. So um, you know, just skip that. It's not really what they wanted. Um, and so basically all of these other, and I can reset. And the only other, this one, which has stores, loads to memory. Also, I can show the cache on this one. So page with our store word. And so the store word instruction was on a register plus immediate. So register 1, which is always 1, plus 9. So at index 10, right, in memory, we want to store the value of R2, right? So if we go to memory, right here, we want to store the value of R2 there. Now, because there's a delay, so we have to wait 3 cycles, right? Uh, to to or register 2, which had 2 in it, to memory address. Even loading it into R6, I think it was. R5. Oh, we didn't. Oh, this is the thing. So we want to load into that, but we're not at right because we want to work back to the register on the last cycle because it was in cache right here. So it just instantly fetched from cache. Um, that, so, um, whoa, did not mean to send that over there. Um, yeah, so that is about, like, is that 4? Yeah, that is about all I have for today. How long did that take me to go through all that? 22 minutes. Yeah, a little too long. Um, but but yeah. So next up for that project, what I want to work on is um we have to benchmark a matrix multiplication and we have to benchmark a sorting algorithm. So gonna work on making sure that the system can handle that, and also fixing fetch to take a few cycles to fetch from DRAM those instructions. So, and then I think we're going to implement AES encryption. So, or some subset, or just some encryption, honestly. AES might be, we're a 16-bit system. AES kind of expects a 128-bit system, like modern systems. So, probably not going to go with that. Um, but yeah, so that is all I have for today. I'm going to go watch Lakers win game 1, hopefully. And then I will be back tomorrow, hopefully for actually something decent and actually doing something other than just showing you the code from what I've been working on all week. So, okay, I will see you tomorrow. Have a good night. Bye.